Hi, welcome to today's class on My Lesson Teacher. Today's class is a continuation of our previous classes on number-based system for Senior Secondary 1. At the previous class, we were able to convert numbers in base 10 to other bases after I did explain to you the different number system that we have. We're able to convert numbers in base 10 to other bases. We also dealt precisely on converting numbers in other bases back to base 10. In today's class, we shall be taking the third objective, which is to convert decimal fractions in other bases to base 10. We have seen how to convert numbers from base 10 to other bases, as well as from other bases to base 10. In this next example, we shall be dealing with fractions. And how do we convert numbers involving fractions from other bases to base 10? I have an example here for us to solve, that we should convert 101.111 base 2 to base 10. We just have two steps to take in treating this. For us to convert these numbers to base 10, we have to multiply each of the digits by the base all raised to a power, and that power is a function of the place values of these digits. That is, what am I saying in essence? 101.111 base 2, I'm going to express it in the expanded form by multiplying each of them by a power. So remember that in our previous class, for us to convert from other bases to base 10, we multiplied this, for example, using the expanded form by saying 1 times 2, which is the base, raised to a certain power, and which we said the power is a function of its place value. That is, the first digit to my left after the decimal, before the decimal point, we'll take the place value 0, while this will have a place value 1 and this 2, such that you multiply 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. So I'm going to expand these digits by, okay, let's first of all assign the place values to each of the digits. This is said to be 0, 1, and 2, while digits to your right from the decimal point will be assigned place values less than 1, that is, negative place values. So the first digit is going to have a place value of -1, the second will be -2, and the third will be -3. So I'm going to multiply each of these digits by the base, all raised to the power based on their place values, such that this becomes 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0 plus 1 times 2 raised to power -1 plus 1 times 2 raised to power -2 plus 1 times 2 raised to power -3. This is the first step in solving this problem. Next, what I'm going to do is to simplify them until I arrive at an answer. That is, this is equal to 1 times 2 raised to power 2 can be said to be 2 times 2, and 2 times 2 is 4, plus 0 times 2 raised to power 1 is said to be 2, plus 1 times 2 to power 0 is said to be 1. That is, anything raised to power, any number raised to power 0 is said to be 1, plus 1 times 2 to power minus 1 is said to be half, plus 1 times 2 to power minus 2 can be said to be 1 over 2 raised to power 2, and 2 raised to power 2 is 4, plus 1 times 2 to power minus 3 is said to be 1 over 2 raised to power 3, and 2 raised to power 3 is said to be 8. I'll simplify further. This is going to give us 1 times 4 is 4, plus 0 times 2 is 0, plus 1 times 1 is 1, plus 1 times half is said to be half, plus 1 times 1/4 is said to be 1/4, plus 1 times 1 over 8 is said to be 1 over 8. You simplify further. This will be equal to 4 plus 0 plus 1 is said to be 5. That is for the whole number part, plus our fraction. I'm going to find the LCM of 2, 4, and 8 so as to add them together. When you are solving sums of fractions whereby the denominators are said to be different, you have to get a new denominator for this solution. So if I'm to add half plus 1 over 4 plus 1 over 8 together, I'm going to use the LCM method. What's the LCM of 2, 4, and 8? The LCM is said to be 8. I have gotten a new denominator for these fractions. To get a new numerator for this expression, I'm going to divide the new denominator, which is 8, by each of the old denominators to be multiplied by the old numerators to get the new numerators for this expression. That is, 8 divided by 2 is said to be 4. 4 times 1 is 4. Plus, I have gotten the new numerator for the first fraction, half, which if you divide 4 over 8, it is still the same thing as half. I'll also do same for the second fraction by saying 8 divided by 4 is 2. 2 times 1 is 2. Plus, do same to the last. 8 into 8 is 1. 1 times 1 is 1. Simplify further. This is equal to 5 plus. Now sum up the numerators. This becomes 4 plus 2 is 6 plus 1 is 7, all divided by 8. And when you simplify this further, your answer becomes 5 whole number 7 over 8. By this, I have been able to convert 101.111 base 2 to base 10. So this is the way to convert fractions, numbers involving fractions, from other bases to base 10. Let's take another example.